Olá,
Hello. Hello, how are you? Good afternoon. I'm Professor Ricardo Primi, and I am here coordinating this roundtable about vertical assessment. Thank you so much for being here. I hope that everyone is enjoying this event. I'm going to first introduce our two speakers of the day. They're going to talk about vertical scaled. First, I'd like to introduce Derek Briggs. He is from the Institution of Behavioral Science in Boulder, Colorado, and he is from the Center for Assessment Design Research and Evaluation. He has a master's and doctorate from Berkeley, and he focuses a lot on learning progression assessment methods. So it's extremely interesting and it has to do with what we're going to talk about today. He's also president of the American Association, American Research Association since 2021. And we also have Professor Tufi Machado Suarez, and he is a professor of the Department of Statistics and of Education and of the doctoral and master's program at the Federal University of Juiz de Fora, and he's also a research fellow. He holds a PhD in mathematical control theory and statistics from PUC Rio University and a postdoctoral degree in statistics.
bom, vamos lá então. Eu vou convidar então para iniciar a primeira
Okay,
apresentação.
so I think that we can begin with Derek. He will begin the first presentation. Professor Derek Briggs, the floor is yours. Welcome. Thank you so much for being here.
Thank you. Let me go ahead and share my screen. Well, first of all, thanks very much to Ricardo for inviting me to present amongst you. I want to first say that I wish that we were in a position where travel was possible, because I have not had a chance to visit Brazil, and it's one of the countries I most would love to visit. And so it's too bad that I'm only getting to meet you all over Zoom. I'm going to be giving a presentation today that's really based on lessons that I've learned in many years now of research that I've conducted about vertical scaling of educational assessments. And the presentation that I'll be giving, I think, builds quite nicely off the presentation that many of you had the opportunity to hear from one of my former students, Ben Domingue, who is at Stanford University. And I had an opportunity to see the presentation that he gave. And in his presentation, he gave a lot of really nice technical details about really what I would call the nuts and bolts, or the specific details involved in creating a vertical scale, and the difference between vertical scales and linking and equating. So all that will come in very handy, and I won't go into some of those same technical details, but instead I'll focus much more on actual empirical studies that I've conducted and lessons that I've learned from those studies that I hope will come in handy for the context that you have in Brazil. Before I get into all these studies and what I've learned, I want to maybe say a little bit more about me than what Ricardo provided in his introduction. I'm a professor of education at the University of Colorado at Boulder. My actual primary home is in the School of Education, not in the Institute of Behavioral Sciences. I do collaborate with them, but I'm in the School of Education. And I am currently the president of an organization called the National Council on Measurement in Education, very focused on issues in particular around educational assessment and testing in the United States, but we have international membership as well. And I serve quite often on technical advisory committees for many large-scale assessment programs in the United States. As you may know, there's a lot of testing and assessment that goes on in the United States. Each state often has their own program. And so I sit on panels to advise many of these states, but I also sit on other panels for consortia of states and for the National Assessment of Educational Progress. I'm on the Design Analysis Committee for that program as well. And I'm also very pleased to say, and I have to tell people because I spent so much time working on it, I need to announce that I have this book that I've finished that's coming out in November. It's called Historical and Conceptual Foundations of Measurement in the Human Sciences, Credos and Controversies. So gets less into technical details and statistics, but into much bigger conceptual and historical issues about what we mean when we talk about measurement outside of the physical sciences. So if any of you are interested in that, you can check out that book. Okay, a little overview of what I want to speak about today. Really, there are three main issues in creating and interpreting vertical scales for large-scale assessments, and I'll break it into these three classes. First, there are design issues that are really important. Then there are methodological issues. Lastly, there are theoretical issues. And I'm going to talk about each of these in the context of my own research. And I think much of what you would have heard from Ben Domingue in his talk, I think what I would have placed primarily within the category of methodological issues. I may place a little bit more focused today on issues of design and some theoretical issues that I think are important as well. So let me, before I get into some of the details of each of my studies, I just want to preview for you the main lessons learned that I want to emphasize and we can come back to at the end of this talk. The first lesson is that I would argue that most problems that people have with their vertical scales comes from a poorly conceptualized design. What I think is very common is, especially people that are very talented with statistical modeling, is to sort of imagine that we can fix any problem with good statistical adjustment. And I think that when it comes to vertical scales, that's very, very hard. Once the design is fixed, there are limits to what you can really do on the back end to correct a problematic vertical scale. I suspect that's probably a major issue with what you're dealing with the SAIB assessments and things that have come from that assessment program. A second major lesson is that interpretations about growth that you get from a vertical scale, yes, they're sensitive to methodological decisions with respect to the item response theory model, the form of linking and calibration and estimation. Sure, there's some sensitivity to that. But by far, the greatest sensitivity is to the choice of common items that you've used to create the vertical scale. And so this connects back to my first lesson, which is that the choice of common items is a design issue. And so if that's already been fixed for you, it's very difficult to change in the back end. Last lesson learned of the three that I think are most important is that the rationale for the choice of IRT model that is often made by testing companies can be theoretically incoherent. And I think that this has some major implications for the interpretability of results expressed on a vertical scale. So those are my three big lessons. And by the end, hopefully you'll understand why I'm saying that those are my major lessons. A lot of what I'll be talking about is based on a program of research that spanned from really about 2008 or so through about 2016 when I was doing a lot of empirical and theoretical work. But this is still an area that's of active interest to me, and I'm engaged in a project right now dealing with vertical scaling that I've yet to publish from, but is underway. So let's start with design issues in the creation of a vertical scale. It might help to sort of first begin by saying, well, why create a vertical scale in the first place? And if you don't have a very good answer to that question, you're already probably in a lot of trouble. And so here's one possible motivation for why I might be interested in creating a vertical scale for a large scale assessment program. It goes something like this. Let's assume that we agree learning is the central purpose of education, or at least a central purpose. Second, that we test students to find out what they know. Third, that growth in what students know is something we want to equate to learning, that if they're showing growth in what they know, that seems to indicate perhaps they've learned. Lastly, that we think that teaching should have a positive effect on growth, okay? Now, if you would accept those four premises, then I think in principle, a vertical score scale is something we really need in order to validate claims 3 and 4 in any absolute sense, right? If you really want to know that growth has occurred, you really seem to need test scores across grades, across occasions, that are expressed on a common scale. Otherwise, you can only answer these in very relative sense, in a very normative sense. But if you want to answer them in any sort of absolute or criterion reference sense, it would seem that a vertical scale would be a prerequisite to doing that. So one of the things that might be really nice if we had a vertical scale, we could draw a picture something like this, where we have a plot on the vertical axis with data. I have something expressed on a vertical scale. And then on the horizontal axis, I have grade. And I might be able to ask questions like, what does growth look like over time? Is it just linear, right? Is there just sort of our typical trajectories linear in nature, or perhaps they show this sort of first quick acceleration, then deceleration? Or it could be the opposite, actually. It starts out relatively slow and then there's acceleration, right? These are empirical questions we might have about the nature of learning. And having a vertical scale, one that we can trust, might make it possible for us to get empirical answers to these sorts of hypothetical ideas we have about the way learning transpires over time. So I would argue there, or I just want to make the point that there are two approaches that one can take to model growth, right? And first, I would say that all growth can be just conceptualized as conditional achievement. And there are two important distinctions I want to make within that. The first is that we have some models that only condition on time, right? And I would call these absolute or criterion reference growth models. But there are also models that condition on prior achievement. And I would describe these as residualized, relative, or normative growth models. Some of you have heard of maybe value-added models. These are examples of what I would call models that condition on prior achievement. And what's really important, if you are not interested in reporting and evaluating growth over time in an absolute sense, there's no great reason to create a vertical scale. This is actually something that got me into this line of research in the early 2000s, when in the United States they had No Child Left Behind. What people were quick to see a problem with that policy was that it only tended to focus on the status of student achievement, not in growth. And there became a lot of interest in the United States in developing value-added models to try to give schools and teachers the benefit or credit for growth they were establishing. At the time, there was the thought that in order to use a value-added model, you actually had to have a vertical scale. Some of my research, some of the findings of my research has actually suggested just really not the case. That if you're really only interested in normative comparisons, the vertical scale is not something that is a prerequisite for a value-added model. So in what I'm going to be discussing, I want to make clear that the reason I think we care about a vertical scale is when we wish to create growth models that condition on time. So anytime you're interested in the growth trajectory and examining the magnitudes along growth trajectory, a vertical scale is really useful to that end. So I also want to say a little bit before I get into some details of results from my studies about NAEP's vertical scale, because from what I understand from talking to Ricardo, and here I apologize that I don't know as much about the assessment programs in Brazil as I would like to, but from what I understand, the SAIB assessment is very similar. It was modeled somewhat on NAEP in the United States. And so it might be helpful for me to say a little bit about what I know about the extent to which NAEP has a vertical scale. And in fact, when Ricardo first reached out to me, this was the first question he had: could you tell us, what's going on with NAEP? Did they have a vertical scale or what? Or what's going on with that? And the answer to this is interesting. So NAEP math and reading tests for grades 4, 8, and 12 were in fact vertically scaled. And I think this originally happened in 1986. I think it was redone again maybe in 1992. Since then, nobody has done any work on the vertical scales in NAEP since I think about the early 90s. And in fact, if you actually look on, and I'll show an example of this, only the vertical scale link exists still for grades 4 and 8. There is no, the grade 12 assessment is now in its own scale. So even that vestige when they did originally create it, it was for grades 4, 8, and 12. It's actually really hard. And I looked in preparation for today, I looked for technical information about the way they calibrated that vertical scale and the design. And I have not really been able to find very good information myself. But there are some examples, and I provide a link here. There's a really interesting report that David Thyssen a terrific psychometrician in the United States, wrote for the Nape Validity Studies panel. And one of the things he says is really interesting as a quote, which that the ethos of the Nape vertical scale is essentially, yes, it is a cross grade or vertical scale, but don't push it. so that's what we really know is that, and I'll just give you an example of where you can see this. So here is an example from the 2019 report of Nape math results. And you can see side by side here, the results being showed for grade 4 and grade 8. They're clearly shown on different plots. They're they never would show grade 4 and grade 8 on the same plot because they don't want people trying to make that sort of direct comparison. However, you can see visually, right, that the mean score for grade 4 was 241. The mean score for grade 8 was 282. So this is a legacy of the vertical scales, that there's this apparent 41-point difference between grade 8 and grade 4 mean scores. And so there's an obvious temptation, right, to say for the users to look at this and to divide difference of 41 points by 4 years and say that on average, kids seem to grow 10 points a year, right? And the report I mentioned before by David Thyssen was to say, yeah, this, is this a bad thing for people to be making this sort of interpretation? Especially when the original vertical scale was created so long ago. So yes, I mean, it is potentially a problem. And it's not something that Nape tries to emphasize at all in the way that they report the scores. So that's a little bit of backdrop. If you have further questions about that, I'm happy to tell you. I just want to point out the fact that I know so little about new efforts around vertical scales is, should be surprising to you. It's not as though I don't have a direct role with Nape. I sit on the technical advisory committee, and I've been on that committee for, 8 years. And I don't think in 8 years, anybody has brought up the vertical scale or, whether we should continue it or, problems with it. So, there you have it. Okay, now let's get into some more issues with design. And so one of the points I want to make is that in creating a vertical scale, what people don't always appreciate is you have to be clear about what you mean by growth. How are you defining growth in the vertical scale? And there are 3 distinct approaches that one can take. 2 of them I think are fairly well known in the literature. The third one is something that I've attempted to add to the literature and is an interesting contrast. So the first 2 come from the book that Ben Domingue mentioned by Colin and Brennan, and they describe a domain definition of growth. So what that means, the domain definition, is the idea is that what you mean is you have test standards that are associated with different grades, and what you mean by growth is that you're looking at performance across the same set of all the set of standards that accumulate across grades. Whether they're present in one grade or not, or in one grade and not the other, doesn't matter. You just think of all the standards that wrap cumulatively across grades. And so that's what you mean by growth. It's the growth across all the standards that are on the test, the domain, okay? I want to contrast that with a grade-to-grade definition of growth. And a grade-to-grade definition of growth, the idea is only those standards that are common across grades are the basis for growth. Okay, so that would be a grade-to-grade definition of growth. And the last one is the one that I've introduced with some colleagues called a learning progression definition of growth. And here the idea is there's growth that you define over a well-defined core concept within a domain, and it crosses multiple grades, but maybe not all of them. Okay, so let me give a visualization that might help make the distinction here between what I'm trying to talk about. So on the left here, you can see this domain sampling approach. And so what's shown in each plane, and I have 3 grades, these little shapes in here are just meant to represent different content domains within a subject area. So say in mathematics, you might have understanding of algebra, number operations, geometry, right? These would be those shapes here. And then the dots within each shape represent specific content standards of what students are supposed to know and be able to do within that smaller domain. And you can see here that if you were taking a domain approach to growth, that it wouldn't really matter the fact that, notice here, this shape that's in the middle didn't appear in the bottom plane, but it does appear here. And this shape that was present in the middle plane disappears here. From a domain perspective, that doesn't matter. What you mean about growth is really growth across all these domains, no matter what grade they're in. That's how you would think about it. If you were talking about grade to grade, you would only focus for any two grades on those shapes that appear across the two planes. So in grade x plus 1, notice that these are common. So I could speak grade to grade about this growth and grade to grade about this growth. The growth would be about these two things together would be what I mean by growth. Now, the distinction that I make with the learning progression approach is you're typically focusing on one domain and you're interested in a hypothesis about how students progress and become more sophisticated across grades. And so that's why you see there are these question marks with the arrows. That's because the reason for that is because it's a real interesting hypothesis you're making, and it's an empirical question about the nature of what growth looks like. And so that's the focus on the learning progression approach, is to learn something about a hypothesis you have about how students are developing over time. Whereas I would argue in more of the domain sampling approach, growth is just essentially defined by that which you have there in the standards. It's less of a hypothesis and it's more of a definition. So the other important design piece beyond defining growth is to establish a common item linking design. This is a nice visualization that gives you the sense of what's involved. Here on the columns, you could see the just different test level that students could take, and this shows the examinee grades. And what I'm trying to show here is the difference between a design in which you have students in third grade taking test items that are harder for them, right? So this would be a case where you have third grade students that are taking fourth grade items. This would be an example where the linking approach is called an uplink. You have third graders, they take items that are harder for them. Here in the middle, we have fourth graders, and these fourth graders in this design, in one case, they're taking items that are easier for them. They're actually taking third grade items. And they're also might be taking items that are harder for them, fifth grade items. So in this design here, in these two middle portions, we have a design with both up and down link items, okay? And then the very top one here is a situation where you have sixth grade students that are only taking items that are fifth grade items, okay? This is not always appreciated, this idea that there actually is an important distinction between whether you're giving students items that are written for the grade below or the grade above them. And so I want to just help make sure that we understand why that's important, right? So this up link versus down link idea, right? Here's an example. Let's say we're talking about grade 4 to grade 5 growth. That's what we want to understand. How much growth is there from grade 4 to grade 5? Well, if I administer uplink common items, here's the question that I'm asking with the uplink approach. What I'm asking is, how would a fourth grade student do on a fifth grade test, right? Because what's happening is I have fourth graders and I'm giving them fifth grade items. So when I'm in effect asking the question is, how would they do if they took fifth grade items? Once I have that, what I do is I compare what I actually observed for fifth graders to, I compare actual grade 5 to grade 4. Okay, that's how I'm getting an estimate of growth. The actual grade 5 to what I see for these grade 4 students taking grade 5 items. Okay, hopefully so far that makes sense. Now, think of a different approach. With the downlink approach, I'm asking a different question. I'm asking, how would a fifth grade student do on a fourth grade test, right? So in this case, I'm comparing the actual grade 4 performance of students to the performance of grade 5 students taking the grade 4 test, right? So an important point is that the answer to these questions may not provide the same answer about grade 4 to 5 growth. Because if you think of this as like an experimental design, they're very different experimental designs. When you're asking the question about a fourth grade student taking fifth grade items, the fourth grade student has not yet had any instruction on the fifth grade items. So it's in effect as if you're giving a pre-test, right? And then comparing to what you observe on the post-test for the actual fifth graders. Whereas in the other case where you're asking, how does a fifth grade student do on fourth grade items? Those fifth grade students have already had instruction on the fourth grade items, but it's been a while, right? So what you're wanting to find out is, okay, how much have they maintained what you've taught them in fourth grade now that they're in fifth grade, right? And so you might actually already think this through and imagine that it wouldn't be necessarily, depending on the alignment with curriculum and to what extent their fifth graders are continuing to receive instruction on the things they were tested on in fourth grade, If that's the case, then the answers to these should be very similar, in my view. If, on the other hand, they're no longer receiving much instruction in 5th grade, you might expect to see less growth, right, when you're asking 5th grade students to take 4th grade items than you would if you asked 4th grade students to take 5th grade items. So often it's the case that with vertical scale designs, you see actually in the linking studies, in the common item design, that they have both uplink and downlink items. And in that case, when you're averaging across these and estimating your linking constant, you're getting an average of these two different designs. And it's not totally clear how you should interpret it, what that growth actually means, depending on the nature of instruction. So which design is better? Well, it really will depend on the conceptualization of the construct and how you think it grows over time and how this connects to the sorts of instructions that you expect students to be receiving in school. So here's just one example of showing you now how this empirically makes a difference from the study that I did with one of my former students, Nathan Beatty. And what I'm showing you here are box plots. And let me just start with the one. We did this for a state's vertical scale in both reading and mathematics. And what I'm actually showing here on the vertical axis is the difference, just in proportion correct metric, okay, between students from a particular grade pair, say grade 2 to 3, when I'm looking at the proportion correct of common items, the same items taken by 3rd graders versus those same common items taken by 2nd graders, okay? And what I'm showing with these two different plots is what I actually learn about those differences for common items, depending on whether I have a backward or like that downlink design or that uplink design. And what you can see is that almost across the board, it's usually the case that the amount of the difference in proportion correct is higher when we look at the items that involve that uplink design. In other words, the case where I'm giving students in the earlier grades, 2nd graders, they're taking 3rd grade items, right? And then I'm comparing the actual performance of 3rd graders against how 2nd graders would do if they were taking the harder items in 3rd grade. And so the point here is that, remember, when you're estimating with all the complications that Ben talked about of estimating linking constant, the sufficient statistic are just these differences in p-values, right? And so the higher that difference, the larger the estimated linking constant is going to be. And so you can see that that's not this choice can actually have an influence on what your pattern of growth across grades is likely to be. And here, this is just showing it in reading. This is showing it in mathematics. You can generally see, just as a principle, beyond the comparison between forward or backward linking, just notice that there was, in this data set, much more differences in performance on the common items in mathematics than there was in reading. That's why these values tend to be a little bit higher than the values in the left here. I'm going to just stop just for a moment here, because this is, often the case that one can show these things and people may have questions. So I just want to pause for a second and see if there are questions either about this plot or what led up to it.
Yes, I am seeing on the chat, but we don't have any question yet. But I think, yeah, it's a hard graph, but I think we got the idea.
Okay.
Thank you very much.
So another design thing that's often important is this idea of what are called item reversals. This is something that Ricardo mentioned that has been observed for SIAB. And what I mean by item reversal is what we expect to be happening when we administer these common items to students across adjacent grades, is that we want it to be the case that the students in the upper grade do better on the item than the students in the lower grade. What you can see here from this study that Nathan and I did is we're showing the actual differences in proportion correct for the common items. And here I've drawn a blue line here to show like where the threshold is for 0. When it's negative, any item that's negative tells you that's an item where students in the lower grade actually perform better on the item than students in the upper grade. And what you can see here is that there are a fair number of items in the distribution where that was the case, where there were item reversals, and you can sort of see where this becomes the biggest issue. Here is as we were moving into the middle school and into high school grades, there were far more reversals at that point. And what I want to show is, what some companies will do with their clients when they're first administering common items to create the vertical scale is one can look at this distribution and see where there are item reversals, and then make the decision, what if we exclude from the vertical scale all items where there are reversals? Well, this is what actually can happen. So here, what we did was to say, well, what if we just excluded all the items with reversals? And the dark line here is showing you the pattern of growth in effect size units, right? So I'm just comparing mean scale score to mean scale score divided by the standard deviation. Okay, so anything above 0 is positive growth. And you can see here that if I take out all the items that showed reversals, I get a noticeably different trajectory of effect sizes than if I included the reversals. In fact, it makes growth look more impressive in effect size units than if the reversal items were included. I would argue that there's not, in the study, one of the things that we did is we actually asked teachers in the state if they could, without knowing, if we just showed them the item, could they pick out an item where there would be likely to be a reversal, right? If they didn't know, because I wanted to be able to say, well, maybe there's a reason if you could say, oh, this is not an item that we ever focus on in our instruction. And then they could tell you that's a bad item to include in a vertical scale because it doesn't align with our instruction. But in fact, that wasn't the case at all. The teachers were not really able to flag for us in advance, these are the kinds of items that would likely to be showing reversal. The argument I make in the paper is that if you can't ahead of time have a good theoretical reason for why an item that you've chosen as a common item shouldn't be included in the scale, the fact that you have a reversal might be sort of going against what you hypothesize, but it's really important information. And it's something you should not throw away, but you should notice and probably act upon, because it's actually telling you that something perhaps important about student learning is that this is something where learning doesn't seem to transfer or generalize over time. So let me turn from these design issues related to the choice of common items and the inclusion of common items in a vertical scale to at least one set of methodological issues. Just briefly, this is a study I did with one of my students, John Weeks. We were able to get longitudinal item response data from the state of Colorado. And so here you can see the design of the data that we had. We had 2 cohorts of students that took the state reading tests over this period of time. And from this, we were able to enact a linking design. And this just shows you a general sense. The vertical linking is actually these horizontal pieces here. But then we also had across the same grade over time, where we were doing some equating. So we were doing both linking and equating. So one of the things that's very hard in vertical scaling is usually the vertical scale is just given to you, and you have a test that's been vertically scaled. This was a rare opportunity where we were able to go back to the original item responses and ask the question, well, we have the original data. What if we thought about all the different ways we could create a vertical scale from the original item responses and see how sensitive growth is to the technical decisions we make about the way we create the vertical scale? So this was the idea of the study, is that we thought, well, one design decision is what IRT model should you use? So we contrasted the use of the Roche model versus the use of the 3-parameter logistic model. Another approach was whether we were going to be doing separate calibration, that is, we're taking one grade at a time and linking it in a chain manner, or whether we're doing it all, trying to do it concurrently. We didn't actually do it all concurrently. It was actually ended up being sort of a hybrid approach that we were using. And then finally, the way that we're estimating theta values, whether we were using EAP values or maximum likelihood values. These are all methodological decisions that different psychometricians may choose different routes in collaboration with their stakeholders. So from this, one of these different, 8 different vertical scales using every combination of these choices, we then took our longitudinal data and fit it through a hierarchical linear model, a 3-level model. And what we wanted to do is just from that project growth from using this model and see to what extent our projections of growth would depend on the design decisions for the different vertical scales. And this just shows you the results. And then the main story here is just to say that, yes, if what you're trying to interpret is the magnitude of the slope on the projection. sure, you will get differences depending on the approach that you get. And so here you can see that the magnitude of the slope, or the amount of growth that you're seeing per grade, was larger when using the three parameter logistic and separate calibration than it was when using the Roche model. That said, what's going on here under the hood is that when you're using the three parameter logistic, it's generally extracting more information. It's essentially assuming that you have a finer scale than you would under the Roche model. And so what it's really doing is stretching out the scale. And so that's what I'm showing on the top of these plots. The variability on the scale is much greater because of the nature of the less restrictive assumptions about common discrimination among all the items. And so you're getting more variability. And as a consequence as well, you're getting more growth in logits, right? That said, once you express these in effect size units, the differences become much less extreme. So part of the answer here about sort of differences you would interpret about growth in absolute magnitude can be somewhat remedied if you're being very conscious about differences in the variability of the two scales. So if there at the end, if there are more questions about these methodological things, I can certainly dig into the technical details. But for now, the main thing I just want to say about that research is yes, it can absolutely matter, but it is less as big a deal as I might have thought it was when I first got into that particular line of research. The last thing I want to talk about, which in my view ended up becoming the reason why I sort of shifted gears from some of the research I was doing in this area, I ended up writing a book instead, was that there really are some important theoretical issues that can easily get you sidetracked. And so I asked this question in the slide: is what you're seeing when you look at a vertical scale in terms of certain questions we're asking, is it real or is it an artifact? And what I mean by that is that many researchers look to vertical scales because they want to answer these empirical questions, like, is growth over time linear, or is it decelerating or accelerating? You remember that plot I showed at the beginning of my presentation. Or you might ask, is the variability across grades staying the same, or is it decreasing or increasing? And here is from a study that Nathan Data and I did, where we looked at existing states in the United States that had vertical scales, and we just wanted to ask the question, in how many cases do we see that the standard deviations seem to be getting smaller, what's known as scale shrinkage across grades? And the lines that were in red were the cases where we saw there was some evidence of scale shrinkage. And so what we wanted to do is essentially just summarize across the states, how often is this happening, right? And this seemed like an important thing to be doing, and an important thing for people to know about. But there's a big but. It's not clear whether you can make this interpretation that these are real phenomena, because in many instances, states are performing additional transformations before they even report the results of the vertical scale. And you can see this actually, you can see this called out as a possibility in Colin and Brennan's book from 2004. They write, the theta scale also can be non-linearly transformed to provide for growth patterns that reflect the kind of patterns that are expected. That's my emphasis. Consider a situation in which a test developer believes the variability of scale score should increase over grades. If the variability of the theta estimates is not found to increase over grades, a non-linear transformation to the ability scale might be used that leads to increased variability. I found this passage in their book just absolutely shocking when I started doing this research, because all of a sudden it suggested to me that what I thought was an empirical trend could just be an artifact behind the scenes of psychometricians working with state developers and saying, oh, we want to see that variability is increasing, or we want to see these sorts of patterns, and just putting them in. Right. And what this really implies is this is actually reasonable if what you think is going on when you create a vertical scale is that you think the vertical scale only conveys ordinal information, then any monotonic transformation is admissible. And you can see why they're saying this, right? So what Ben and I did in one of our studies is we actually, you can see this plot here. This plot shows different trajectories of growth, right? And it's expressed again in effect size units, right? And I think if you looked at this, wouldn't you agree that this is telling us very different patterns about how students are growing across grades 3 through 6, right? You know, this one in the middle here, growth is constant, right? in the other one here, growth is increasing. It's, there's increased growth over time. This looks like growth is really decelerating, right? So you're getting all possible patterns. Well, there's a secret to this plot, which is that it comes from the same data, right? What I've done is I've taken the original data and I've applied, in each case, different monotonic transformations to the original data. And so I can get any story I want about the patterns of growth by applying these different monotonic transformations, right? And so part of what we do in the paper is to ask the question, if that's what you're doing, when will this matter, right? And what we actually show is that, again, if what you're doing is trying to make only normative comparisons, typically kind of value-added model comparisons, even these severe transformations end up not mattering that much. Where it matters a lot is, again, if you're looking at growth trajectories, like in a 3-level hierarchical model, and you're trying to make sense of the slope over time, then this matters a lot. And you can't really trust the inferences you're doing if you're changing these sorts of scale properties. So what this really boils down to, the theoretical issue is, when you're choosing an item response theory model, and you remember one of my lessons learned was to say that I think what a lot of testing companies are doing is sometimes choosing an IRT model on a basis that's theoretically incoherent. A lot of the argument often is, what we should do is we should just find out which IRT model best fits our data, and then we create a vertical scale with that IRT model. Well, that tends to bias the choice towards the more multi-parameter models, like the 3PL model. It's more likely the 3PL will show better fit than the Roche model. So you can end up having a case where you say, look, the 3PL fits better, so I'll create my vertical scale with the 3PL. There is, however, a problem. If the argument you're trying to make about the vertical scale is that you want the scale to have interval properties, and that's really important to you, there's a case for how that could be accomplished if the model fits the Roche model. It's much harder to make that case for an interval scale if you're applying a 3-parameter logistic, right? So there's the trade-off. Yes, you found a model that fits better, but you're losing the whole purpose of the vertical scale, which is that you want it to have not ordinal properties, but interval properties, right? And I think many testing companies don't appreciate that what they're giving up by fitting the 2-parameter model or 3-parameter model might be the whole kind of warrant for having the vertical scale in the first place, that it allows you to make these interpretations of magnitude that are invariant. And so this is an important trade-off. That said, I don't want to imply the use of the Roche model is somehow magic. It is the case that if you use the Roche model, you may find there are many items that really don't fit the Roche model. But what that does is bring us back to design. And it says, for those items that don't fit the Roche model, we need to understand why. And we need to do a much better job on our design to make sure that it does, if we want to interpret growth in a way that is meaningful and has certain properties, right? I get into this a lot more. Like, this is something that, I was able to, Ben was such an incredible student. And, when he was coming to me for a dissertation idea, I said, well, let me think about something that I wish I could do if I had the time and I had your skills. And so I attracted him to essentially write this dissertation in which he showed how you could come up with an empirical method for checking this assumption of equal interval properties. And so this is what he did his dissertation on, which was published in Psychometrica. Okay, let me just go to this last set of practical recommendations. I would like to argue that the core of any vertical scale is a fairly simple experiment. And sometimes I think we lose track of this because we get so caught up in some of the more esoteric decisions we have to make around the use of item response theory. What model should we use? How should we do the calibration? Are we doing ML estimation or EAP estimation? Is it concurrent? Are we doing stocking lower? You get into those details, but you forget at the heart of the design is just this experiment. What's happening is you have groups of children at different ages and grades, and they're given the same test items. And what we expect is the older student should do better on every item. If they do, all seems well. If they don't, or if the difference is small, it raises some important educational questions. So I don't want to let these technical details of IRT, estimation, linking, and scale properties obscure this fundamental idea. So last thing I'll just say is that when you're doing a vertical scale, be careful about asking a question when you're not prepared for an unexpected answer. Thank you very much.
Okay, thank you, Derek, very much. So that was really great talk, and brought a lot of points. I'm sure everybody enjoyed a lot. So I will keep the questions for the end so we can discuss the three of us. And so now I will call Tufi, okay, Tufi, to give your presentation, and then in the end we can come up the three of us to discuss it. Okay. So então vou chamar o Tufi, vamos lá.
Ok, tá vendo minha apresentação?
Hello, can you all see my screen by now?
Bom, eu vou apresentar então a ideia das escalas verticais dentro de uma perspectiva.
Okay, so I'll be talking about vertical scale.
Mais claro, tentando alguns problemas que nós temos encontrado com a produção de escalas verticais aqui no
And I wanted to touch on some of the issues that we have found in Brazil with SAEB, as well as municipal and state assessment.
também tentando visualizar algumas alternativas possíveis.
We're trying to come up with some alternatives.
Bom, no Brasil nós usamos o termo equalização vertical, né, que vem uma
Now I
tradução
wanted to talk about the concept of vertical scaling or linking.
nos Estados Unidos da América, por exemplo, né? Mas tecnicamente eu tentei conseguir algumas definições sobre o vertical
On the
scaling.
slide, you see some definitions of the concept of vertical scaling. Here's a definition by Colin and Brennan, who state that vertical scaling is a mediation process that creates measure for similar constructs, but in different difficulty levels under a same scale. This is a very comprehensive concept and definition, and this is pretty much what we try to do. What we aim is to measure students' growth from one grade to the other. After the scale has been built, we want to build all those measures using the same scale as time goes by, as well as follow up the results, evolution, and students' learning results throughout the years. In Brazil, SAEB, as well as municipal and state assessments and different educational systems use this type of measurement. Municipal and state assessments want to not only compare these measurements as years go by, but also compare these results with the results from SAEB, which is the basic education assessment system. This is SAEB's vertical equation, vertical scale.
Conhecido na literatura, denominado como item não equivalente grupo.
These are the common item non-equivalent groups.
Mas basicamente nós temos 3 anos medidos no SAEB, o 5º ano do ensino
In
fundamental.
the SAEB test, we measure students' growth at the 5th, 9th, and 3rd years. Actually, 5th and 9th year of elementary school and 3rd year of high school.
São introduzidos cadernos de teste comuns aos alunos dos diferentes anos escolares.
The same tests are given to students of different school years.
Tipicamente, utilizamos
And we want to compare those results. We got the 3PL models with multiple groups and unidimensional models for TRI, as well as EAP methodologies to estimate proficiency levels. These parameters are estimated using the multiple groups model, and the same proficiency level is considered for all of the groups. SAEB, the Basic Education Assessment System, is used as the foundation for all of the educational initiatives that we got for basic education in Brazil. There are many challenges involved with the process of building vertical scales, and Mr. Briggs has mentioned some of them. From a technical standpoint, I would list three main challenges. The first one is the measurement acumen. This precision rate is rarely calculated due to its theoretical hurdles. The number of items is usually small, and to make matters worse, there are some biases to the vertical scale, as Mr. Briggs has mentioned during his talk. We usually include more difficult items in the 5th and 9th years, and harder items in the 9th and 3rd year of high school, which can, of course, lead to different biases because we don't really have a randomized sample as we assess students this way. Progressive schemes, such as scales with the 3rd, 4th, 5th, and 7th years, would also reduce the equating process problem, but will always have some bias. Number two, the challenge of the item different way of functioning. The item parameters are the same regardless of the number of students who are part of them. So we assume that there is no different functioning amongst different grades, and if there is any kind of differential functioning, this should be identified and they should be flagged as different items. However, there may be different reasons that make matters worse. If we have a unidirectional differential functioning, if we focus more on one group than others, then the identification is compromised from the very get-go, because to identify these items, we need a certain proficiency level that can't be compromised by this, and that can create problems in some situations. Finally, one of the issues that has been mentioned by Mr. Briggs has to do with the different dimensions of the test. There are three different scenarios on the slide. First, there may be important dimensions that could explain these answers to each of the items that are not reflected in the general or single scale. For example, are there competencies and skills at a certain grade that wouldn't be properly reflected in one single measurement? Second question with regards to the assessment dimension. The unique measurement produced by the unidimensional model could be contaminated by specific dimensions, and therefore the effects of the secondary dimensions could affect the behavior of the global scale as years go by. Finally, a subjacent dimension, or a non-intentional one, that hasn't been considered by the model, would that change the functioning of common items in this group of students? These questions are asked by experts, different ways. And this could imply the way we compare results in different grades, but also in different years. Some examples of these issues have been stated in literature, one of which is the scale shrinkage, which is a reduction in the variability of measurements inside groups which is different from other methods. Amongst different authors, some have said this has to do with proficiency estimate methods that would impact lower and higher proficiency levels, and other authors will say that this issue has to do with the dimensions. Derek has talked about his work already. I just wanted to quote it really quick. Briggs and Wicks in 2019 assessed the sensitivity of value-added modeling to the creation of a vertical scale.
Quando se compara diferentes métodos para vertical scaling, ou para o...
There are different methods for vertical scaling or vertical linkage. The authors conclude combining the growth of the mean and variance of measurements that are similar standards in different proceedings to equate this absolute growth of the measurements, and there are differences of around 20% of the standard deviation, which may influence the interpretation of such growth. They also conclude that the vertical scale construction method has had a significant impact in the precision and classification for particular methodologies of added value. What basically the authors tell us is that according to the vertical scaling method we use, different interpretations are possible. And there are different implications on the way schools are classified. We don't really know which component of the vertical scaling method would produce that. In Brazil, some problems have been reported, one of which is a substantial growth of measurements in fifth year of elementary school. Part of these students have reached the same level as 9th graders. And that raises several different questions. Some of these questions have to do with the dimensionality of the test. For example, if we're talking about a math assessment, then a 5th grader that has 240 points proficiency level will likely be at the same level in the 9th grade, and they would be able to solve many of the problems in such year. For example, the Pythagorean theorem. However, maybe the way we interpret scale is not adequate according to one single dimensionality. We also look into comparability throughout the years. Usually, state assessment will use SAEB groups to compare them, either that or items of the assessment itself. This repeat year in, year out so that we can compare them. Now, according to the way these studies are done, depending on the set of items that is used, different results will be seen. So if one uses the items of the assessment itself for this linkage process, then the SAEB items will be either easier or harder as compared to the original parameters and vice versa. This is something that does not happen often, but it does happen in some cases. And sometimes it is hard to solve such issues if we do not have comprehensive analysis to try and find where the problem lies.
Relacionados, por exemplo, à sobreexposição de itens ao longo do tempo, mas, de qualquer forma, é um problema que bate na questão de linkagem. Recentemente, na literatura,
Recently in literature, it was suggested to use bifectoral models for vertical scaling. For example, Lee and Richmond in 2009 proposed a vertical scaling procedure based on bifectoral modeling. I'll talk a little bit more about this later. For assessments based on testlet, comparing its performance with the 2PL IRT and multidimensional models that are just more broad. And they concluded that the bifectoral model could offer more precise measurements for these types of assessments than one-dimensional or multi-dimensional models. However, on the other hand, the scale shrinkage phenomenon does not happen in the bifectoral model. Other proposals in that sense are also known in literature. Kai, Yang, and Hansen in 2010, they expanded this type of model. Okay, and just to remind our participants what a bifactor model is, you can see it right here. It's been very used in psychometrics since the 40s actually, or even in the 30s actually, as you can see down here. And for those of you who know the bifactor model weight structure, you can see that each item has different weights in a specific factor and an overall factor. And in the other specific factors, it'll be 0. That is the idea of the bifactor models. So the item has a weight that's different to 0. This is a more frugal model, I would say. Recently, there was a proposal to use the bifactor model for several groups and applications. And this is for vertical equalization. And there's this paper by Lee and Lizitz, and this is simulated and real studies. And they concluded that this type of model can give a good estimate of parameters and skills that the traditional one-dimensional models overestimate the discrimination of items. Bifactorial models can offer more accurate estimations, and the means and variation estimates are also more precise through these types of models. Okay, this is a typical bifactorial model based on the 3PL structure for multiple groups. You can see it right here in this equation. Those who work with this recognize this formula immediately. So you have several dimensions, and the bifactorial aspect is here. So you will have a specific dimension or an overall dimension if the construct between different grades and specific factors as well. So in this specific structure proposed by Lee and Lizitz, you can see that the items have a discrimination that's different than 0 in the overall factor. In our case, this was applied to the lower grades. Okay. Now I would like to talk about this slide right here. I think that several issues have to be researched here in Brazil. And I added 4 issues that I think should be researched in Brazil on my slide. First of all, the equalization method or the vertical equalization method of SAEB, has it presented consistent and coherent measurements throughout the years? If not, what component of the method has produced this inconsistency? And in what measure is the hypothesis of one dimension consistent for the models of IRT used at SAEB for multiple groups? Are there relevant dimensions that are being not considered, let's say, in the measurement of SAEB and that could and should be considered somehow and could be used? Are there dimensions that are interfering in the SAEB scale and that are undesired or simply should not be reflected overall because they could affect the coherent analysis of the results? So I started just asking some questions and trying to answer them. And so we decided to carry out a study, the SAEB 2009 study, with multiple groups. I mean, this does offer some difficulties in terms of methodology. The advantage of the Bifector model is that it's more frugal, let's say, and it's more limited. So you can solve certain issues regarding the estimate, and that's very important. So first, we used our own software. It was developed at MATLAB, and it's now migrating to R, and it's based on MCMC techniques for multi-dimension and multiple types of structures, and also the MIRT, which was developed in R, and it has several estimation techniques. It allows you to add restrictions to your models, and that way you can have a bifactor model for larger groups or for multiple groups. So what we did was we had the math test of SAEB in 2009. There was a sample of 50,000 students, about 220 items. It was 3 school years. It's a partial study because I don't have access to the items themselves. So it's not possible to complete the dimensionality analysis. We use their educational theory to carry this out. It would be interesting to be able to study the dimensions, to be able to complete this study so that it isn't only a partial study. And here you can see the measurements using the bilog mg, and here the overall factor using MERT, MIRT, and the specific factor that corresponds to the school year, to each school year. And for example, for 5th grade, the correlation between below mg and the overall factor is 0.982. And in 9th grade, 0.99. And 3rd grade, 0.99. So I specified some specific factors because my idea was to measure what isn't being measured through the overall factor. There's a high correlation of the measurement obtained by the one-dimension scale with the overall factor of the bifactor model. And there is low or inexistent correlation between the scores of the specific factors and the overall factor and the one-dimension measurement. So that shows that here we haven't measured these factors in the one-dimensional scale. This is an analysis of the percentage of variation. You can see that we have some overall and some specific factors. You can see the different school years and grades. And we have an ECV of 0.89 approximately. Since they're octagonal, the literature says that an ECV of 0.9 is a one-dimensional model. But since I just considered one specific factor for each grade, it is possible that this ECV could drop more, especially if we consider models with more dimensions, for example. That's something that I still have to research. Contrary to what Lee and Lisitz thought, not all the content in a school year had a weight that was different to 0. Some items did present weight that is close to 0. And what does that mean? Well, two things actually. First of all, that I need to be able to interpret the information regarding the factors and the school years in order to be able to understand and better interpret this specific factor that I created. It's a limitation that SAEB has. That's why I'm migrating my studies a little bit towards state assessments where I do have access to the items. And the need to create models that have more factors, more specific factors. That way we can see what other dimensions appear that we haven't been seeing or that we haven't been measuring, for example, in our one-dimension scale. Okay, well, these are my conclusions. There are other studies that should be carried out. The bifactor model proposed by Lee and Lisitz in 2012 presents estimations for the overall factor that are highly correlated with the IRT model, which is one-dimensional. And we can then say that the overall factor is practically the one-dimension factor or bilog. That is for SAEB. And the specific dimensions associated with school years have no correlation or very low correlation with this overall dimension or this one dimension. There are, however, constructs that are not being measured or reflected by the main dimension. So, what we have to do in this case is analyze and interpret these dimensions and other dimensions and that may be created using these bifactor structures and assess the need to measure them or not.
The bifactor model, despite slower, still has some estimate issues and we have to test other programs. Some of them are available, such as the IRT Pro, FlexMirt, as well as a program that we have developed ourselves. As I said, We also have to interpret the specific dimensions to better understand them and to define how important they are, especially as compared to the assessment system. We also have to study the evolution of these measurements as time goes by. We need to use the bifector model and the unidimensional model as well. We have to assess if any of the issues that we have observed in practical terms are due to other dimensions that may or may not be impacting the scale evolution. Now, to do that, correlated constructs may be useful. And of course, this should be extended to other disciplines. I chose math because that's my area of expertise. On the slide, you see the bibliography, and I guess that's what I had to share with you. If you have any questions, I'm at your full service. Thank you very much. Well, thank you for your attention again. And that's it. Over to you, Ricardo.
Obrigado, Tufi. Deixa eu só ver aqui se...
Thank you, Tufi. Thank you. Can you see the three of us already? Shall we start the debate?
Então, obrigado, Tufi, pela apresentação.
Again, thank you, Tufi, for this very interesting presentation. Actually, both presentations were great.
Eu não sei se a gente consegue os três aparecer na tela ou não.
Can you maybe pin everyone's images on the screen?
Eu vou colocar então a primeira questão para o Derek.
So here's the first question to Mr. Briggs.
Here, that was about, we saw one of your graphs that the effect size it goes down, right? So you have more, it seems more growth in lower grades than higher grades. So one question that was raised is, does this mean that the students on the later grades, like high school, learn less? Or no, or is this... and also, I also noted that you have more reversals on the high school. That's also happens here in Brazil. So is there any like reflection about that or interpretation about this pattern?
Yeah, it's an excellent question. So there are at least two ways that one might answer that. One of them is just, again, to say, well, it kind of depends on what common items you picked, you know? So like, for example, I think that there is this idea, like in reading in particular, that it's like there's some theoretical reason why you might think that the things that you are interested in measuring about reading comprehension, that there's less dramatic gains in the student can demonstrate in their ability to show reading comprehension, unless you dramatically increase, I think, the complexity of the text. And it may well be that, you know, text complexity is staying relatively constant by the time you get into high school. And so you're just not going to see with the common items, you're not going to see that kind of a big shift. But I would just argue, again, it really depends, like if the general construct, and this maybe connects a little bit to what Tufi was talking about, if in fact there's construct shift, right, then all bets might be off. But the problem might be that the construct that you might really care about in the upper grades is not consistent with the construct you were conceptualizing for the earlier grades. And it could be that earlier grade conceptualization is carrying through and depressing the amount of growth that you would get, right? So that's where it's like a combination of two things I was saying. One, it's going to depend on choices that were made about the design of the vertical scale and what sort of common items were privileged in doing that. And the second part is that, you know, especially with the situation you have in Brazil, where you're with SIAP, where you're going for such a long span of time, you're putting a lot of pressure on a unidimensional vertical scale when you do that, and it's probably maybe not so advisable, like to just imagine that there is this one dimension that spans that amount of time. So that might explain why you might expect to see these reversals on SIAD, because like the things that were the focus, this is more now in mathematics, I think. Like, I think there is an example given of like the Pythagorean theorem, right? But like, that's a very time specific, like you learn to use it at a very specific time, and you might get rusty and not be using it as much later. And so, maybe that's what's going on, that sort of situation. So, but I'll turn it over. Maybe Tufi has some thoughts on that question as well.
Yeah, so I would just say another question to you, and then I will ask one for Tufi, okay? Just to, because it's the same topic. Tufi showed the design of SIAB that was very nice, and after your presentation, so we see that we use uplink items from 5th grade to 9th grade, and downlink items from 12 to 9. So from design considerations, so do you have any clue about what can happen when we do that? Because that's a kind of a choice of design, like you said, right? So this, we have been seeing some kind of shift towards, as we see like over the years, we see a shift towards the 9th grade, like the average, like they are going down, and so they're increasing a lot from the 5th grade, but not too much for the third. So do we have any clue, any idea about this, or what is the implications of the design?
Well, I do think it's the case that generally speaking, like as I showed, you're more likely to see higher grade to grade growth when using uplink than relative to downlink, right? So that just goes like, if what you're doing from like 9 to 12 is using downlink, like just by itself, I would argue that you're likely going to see less growth than if you had used uplink, right? So that's one thing there. The other thing though is that there's what I don't quite understand about the design as to what extent this is being maintained. That is like periodically, do you keep administering that same design so you're able to check like how the linking constants might be changing? Because there could be drift in the linking constants, and that's what could be possibly leading to this sort of regression. But it'd be hard for me to say without knowing more about it. But a lot of programs, like for example, with NAEP, I mean, they are no longer really embedding these common items anymore. So everything about that connects those grade 4 and grade 8 in NAEP is based on common items from like 20 years ago. So it's like, and those common items should be sensitive to instruction. And if instruction has changed and curricula have changed, it's unclear how much you can trust the growth that you have shown based on the vertical scale.
By the way, thank you for finding that point, because I was like looking, it's very difficult to know with this, thank you very much. So I will ask a question for Tufi. Vendo essa ideia.
Now, Tufi, the general factor and the group factor divided by grades is really interesting. Now, for these items that weigh more in the group factor, do you believe there may be a difference right there? Now, connecting to what Mr. Briggs said, do you think we can see this construct shift because of the group factors? Do you think the construct is changing, for example, in the 3rd year, and moving towards a different dimension that we just can't grasp towards the 5th and 9th year? What about your analysis? Would you have any comment on that? The differential factors and the difference in the construct. Do you think we can test that? Maybe in the 3rd year, we may be assessing growth less than we should, somehow.
Acho que você tá mute aqui, que você vai soltando.
Tá, ok. Eu acho, com a análise que eu fiz, ia só um shift na resposta. Mas na análise que eu fiz, eu acredito
Well,
que para a gente mostrar
based on my analysis, I believe that can be proven.
há uma relação de vícios unilaterais
The relation between the unilateral and specific dimensions. Well, I believe this is a dimensional problem that hasn't been assessed.
preciso aumentar
These differences may appear in different dimensions, but we have to expand the models to be able to assess that, to capture that. That is one of our hypotheses. But to capture that, we would have to increase the number of constructs we measure. And that is a challenge, considering the SAEB structure, the different tests we have. Well, that is a challenge in terms of the estimates. In our program, we have tested unidimensional data, and that works really well. But when we look at the real data from SAEB, then things get tricky. It's hard to estimate multidimensional models. Even for multidimensional models with few options, we see some problems with estimates anyway. That happens in MERT as well. Now, if we can find a specific dimension connected to these common items, then that may be an indication that we have a problem, and that this problem may have to do with the association between those items, and that does not necessarily need to be connected with specific school items, but that depends on expanding the dimensions of the models we're working with, Ricardo. That will allow us to have better quality estimates.
nosso grande desafio para esse momento.
And that is the main challenge we have as of today. This unilateral difference connected to broad items that have clear origin or source, we can't tell if it's connected to a specific dimension or other dimensions that may arise from the model itself. This group of items has been thoroughly exposed to the assessment processes in the country, and because of that, the parameters can be modified as years go by. And that is something we have to further research. That's interesting. You know, just by looking at common items and looking at their specificities, that already provides us with interesting data, because common items should factor into these general factors, ideally speaking, I think. Yes, we should focus on general factors and not on specific factors. I do not believe that is, but that's a good question to research, I guess.
Ricardo, I want to share something. Can I share something about that idea?
Yes.
This is just an idea. I just wanted to share this idea that we had for how to look for the presence of construct shift. And sometimes the difficulty with the bifactor model is the bifactor model is treating construct shift like something that you can remove by specifying a secondary factor. But sometimes what you're actually interested in is just figuring out where it's happening, if it's happening, right? And so what we tried to do in this analysis is we first looked at just specify first of all, it's hard to find evidence of more than 2 dimensions when you start looking into these items. There's generally so we did is we specified a 2-dimensional model, and then we created these vector plots that show like where are the items loading most strongly, right? And so you can see in these vector plots, like, and this is like a lower grade, that it's sort of evenly split among the two factors. But then when we got to grade 5, look, you can see that like if you again specify a 2-factor solution, it's loading more strongly on whatever the second factor is. And we don't know what it is, but it's loading more strongly. And then we looked at the common items to see whether the common items, like what are they privileging, right? And you can see the common items here are more consistent with what we're seeing of the lower grade items than they were of the upper grade items, right? So like, I think this is a way to like, you first have to convince yourself, like, what is the nature of the construct shift, and like what's causing it, and is it worth pulling out that construct as a dimension worth modeling in its own right? I think like one of the like I love bifactor models. I should just say I think they're really fascinating. You know, I teach them to my students. However, I just, you know, they aren't likely to give you a substantively different story about growth. You know, and you could see that in his correlations, like the general, like if you're just focusing on the general factor, it's not going to be much different, right? In some ways, the part that you're most interested in are the secondary factors, but they aren't measured very well. You know, so that's why my approach is more to say, instead of trying to do this multidimensionally, which I find very, very hard to do, is like theoretically, can you identify a different construct or a different dimension? That's why I take this learning progression approach that you think is worth modeling, right? And like, let's take it one scale at a time, you know, as opposed to like saying, oh, we have this very complicated construct that's shifting over time. Can we somehow, you know, figure out a way to model that like at once? I'm skeptical whether we'll have much success with that. That's you know.
No, that's interesting. Because sometimes also they are correlated, right? So, and then they become like merged in one factor, right? Even if they're different things. So one question about the Rash model and the debate about like interval scales, and I learned this from Margaret Vu. She discussed a little bit about the Rash model, and then there is this thing that discrimination we model as constant, but we know that this will reflect on the standard deviation of the scale, right? Imagine you have two sets of items, and in the next year have more discriminative items, and then I assume that they have the same slope. The distribution, the standard deviation of the second the new, like the year, will be higher, right? So we'll have a problem of scale. So, and how does this affect, like, so there is no way to like ignore this thing. Just a thing where it will show up, like the discrimination will show up in standard deviation of the distributions, and not if I was Rash model, right? So how does this? So I don't know if you have any reflection on that, or study how does this reflect on the growth measure, like, because you showed us, like, right? So there is some like more deviation in one of the studies that you showed and less deviation on the Rash model. I was thinking that I was expecting the opposite, actually, because usually the Rash model is always 1, right? And the 3-parameter model sometimes have lower discrimination, so, and then it becomes less variable. But anyway, so, but you found the opposite, right? Anyway, I don't know if you have any clue on that. Or
I mean, it's probably more complicated than I could answer in like a minute, but I would say that like the basic idea is this: is like, what are you assuming about the unit of measurement, right? And like, do you have a well-defined unit? And what the Rash model assumes is that there's sort of a constant unit that you can use, and it's essentially saying, like, when you do it for the same data, the Rash model is essentially saying that you can specify a less fine-grained unit. Like, you know, that we can't make as much a fine-grained distinction as you can under the 3PL. It's saying that some of that is an illusion, essentially, under the 3PL, more or less, you know. And it's like, the problem is, like, the Rash model in this context might be wrong in the sense that you really do have varying discrimination among the items, right? And so, the Rash model won't fit, and like it will violate the premise of that model. And so you just you can't really make a case for an equal interval scale. And where that becomes a problem is on interpretation. Like if you use like what Nape uses, item mapping, as a way to help people understand different reference points in the scale. And so you can pick 2 distances and choose reference items to help people understand how much movement that represents. The problem is that what people don't realize is that if you change the response probability where you mark the item, that distance will change under the 3PL, depending on whether you use 50%, 2/3, 80%, 30, that distance will vary. But in the Roche model, it stays the same, right? So it becomes a concern. So yeah.
By the way, this is one thing that we use here, this kind of item anchor, right, to interpret the scale. So we use this one side also. Yeah. Okay, so let me see. Let's the link. So one question is about this. There was very interesting, the domain interpretation of growth, right? It's kind of a multidimensional, right? So you have all these dimensions, and you're just looking to, if you have a growth in everything, any aspect of the concept, right? It's kind of does this contradicts with the idea of like more IRT that is like reflective, like there is one latent variable that explains the probabilities, and because it's more close to kind of not a reflective model, more a construct. What is the naming? The other name, or where? Formative model.
Yeah, well, it's pretty consistent with Colin and Brennan's sort of perspective on like what they're pretty skeptical about IRT, period, right? And so they just regard it as, you know, something that you're doing to facilitate equating for the most part, and they don't really trust the unidimensionality assumption very well. So, you know, when they would specify that sort of domain approach, it really does put pressure on the unidimensionality assumption. Like that's where you might, when that's the way you're designing things, that's when you might be the most concerned about construct shift, right? Which is why I like the approach that I take, where I am willing to do a unidimensional model, is because I said I'm not taking a domain-based approach. I'm specifically focusing on one core concept within like numbers and operations, like fractions or something, you know. And then I think you can make a stronger case for there being maybe one scale.
So, tá tão interessante que a gente acabou passando do horário aqui, né?
It's so interesting.
We passed a lot of time already from our time, so.
Tem umas perguntas do Wellington, não sei se.
Eu não vi aqui. Você quer fazer, Tufi? Pode
There's some questions in the chat. I don't know if you would like to answer them, Tufi.
Bom, uma pergunta é aquela, nas escalas, o maior crescimento.
There's one question here about the growth curve.
Nos anos mais extremos, né?
They're asking about a slide that was comparing the students between math and reading, and that there's a drop in performance, and if that means if students are learning less. First of all, we don't have a ratio scale.
Mas eu tenho palpite de que ela não é uma intervalar exatamente em todo.
My guess isn't that it's an interval model.
Localmente intervalar seria termo mais adequado.
I think it's like a local interval. That would be a more adequate term. I don't really know how to specify that, to be honest. And I think that this has to do more with some estimate choices that were made.
Fazem com que as diferenças das médias entre os
because then the mean between different grades, for example,
ela constrange a medida da proficiência na direção da média global, que é a média do 9º ano. Então,
when we're comparing different grades, we're going to see that maybe there's an inflation, let's say, in terms of level in the 9th grade.
Essa mesma intervalo de crescimento.
And the growth interval in the 9th grade may not be the same as the growth interval in 3rd grade, for example, or 5th grade. So we do have to be careful when we analyze this. I'm not saying that the interval aspect of this scale isn't
tão grande, tá?
As wide.
Eu acho que a nossa escala é mais
I think that our scale is more about intervals and local intervals, if I can be specific. There is something written about that in the literature. And in our case, I think that it has to do with the choice of estimation.
que é feita. No caso do Saeb, deve ter alguma
Saeb
influência sobre isso.
has maybe some influence on that, I guess.
Isso. A pergunta aqui, né, foi se a gente tem uma escala sigmoide ao
Yeah, the
longo
question is if we have a sigmoid scale for the different grades. That way it grows a little bit in the beginning and at the end of the scale, and it grows more in the middle of the scale. So we have downlinking because we're calibrating from 3rd to 9th grade. This was shown in the studies that this shows less growth than if you invert it, right? If you put something harder in the 3rd grade and easier in the 9th grade. And another point is the construct change. So if you change, for example, if the scale is based more on the 9th grade construct, then maybe we're not measuring the 3rd grade growth as much. But of course, this also has to do with how everything is defined.
A gente cobriu todas as questões, né? Não sei
Okay, well, I think we answered all the questions. I don't know if there are any more questions, comments. We're a little bit over time.
Então, bom, eu queria
Okay.
agradecer muito.
Well, I'd like to thank Derek and Tufi so much. This was an amazing, enriching roundtable. I learned so much with you, and it just makes me want to keep studying this. And I hope that we can meet in person, bring Derek to Brazil. That way he can see Brazil, see our beautiful country, and we can talk more. And so you can have different experiences too. Thank you so much. I
Thank
hope
you. It
that
was a
we
real
can all
pleasure.
meet soon.
Real pleasure. Thank you. Really appreciate a lot.
I hope so.
Tufi,
Thank you, Tufi.
brigadão.
Abraços.
Valeu, um abraço. Até mais, pessoal. Até amanhã,
Thank you
então.
so much. See you soon. See you tomorrow. Bye bye.